Hello, Honors Algebra 2, and welcome to the last lesson in Chapter 3, kind of the grand finale here of solving systems of equations, of matrices, and everything we've talked about. So, Chapter 3, Matrix, Day 3, essentially, notes. How do you solve systems using matrices? So, we're going to combine our solving systems with a matrix here. So, solve each system using RREF. Now, this is not on the test, so to speak, this notation here. Rather, the name is not. This is referred to as reduced row echelon form. Okay, in linear algebra, okay, what essentially ends up happening is there's a matrix made up, and it keeps reducing until you find the solution. So that's what RREF stands for, reduced row echelon form. That particular bit won't be necessary for you, but that's what it stands for. Anyway, how in the world? So let's solve each system using that. Now, I know that you're like, well, you could just use elimination, but let's use this using the matrix. So the first thing you're going to do is to solve these using a matrix. Make sure that your x's and y's are all in a nice column and that they're equal to everything else. You might need to rearrange, but make sure, step one, arrange your columns as so. So you want x, y, and equals. When that's done, you're going to make a matrix out of the coefficients. Okay, so we're just going to write -8, 16, these are the x's, -2, 9, those are the y's, and then 14 and 17. And what do we have here? We have a good old 2x3 matrix. Okay, so second, I would write the matrix down you intend to use. This is kind of like your work that I will be checking. 3, put in the calculator. So remember that second matrix, over to edit. If you already have a 2x3 in there, you can just edit right over top of it to put these numbers in. -8, okay, -2, 14, 16, 9, and 17. Okay, make sure you leave the matrix, and then we're going to go back in, this time over to math in the matrix window. So matrix, might want to put that down, to math, and scroll down till you see RREF. Might be different number on your calculator than mine. Not REF, RREF. Hit that. And then call out the matrix that you typed in. So select the matrix. And hit enter. Boom, 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 boom. Now, what is left is, okay, I'm going to write this down. 1, 0, -4, 0, 1, 9. And let's think, okay, this is correct. Let's think what this may represent. Okay, in an algebraic sense, what this represents, if these are our x columns, it's saying we have 1x plus 0y equals -4. In the next row, it's saying no x's plus 1y equals 9, which means 1x equals -4 and y equals 9. Boom, 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 boom. Kind of magical how you can do that in the calculator. Now, I know with a system of two variables, that might have taken you longer than just to do by hand. Where this really comes in handy is our system of 3 variables, and it's really the same exact process. So let's look over at number 2. Okay, step 1, our columns are R, S, and T, and then are equal to from there. Now, we are going to be making a little bigger matrix, so 2, -5, -6, -3, 3, -2, 5, 1, 1, and 12, -3, 30. Now be careful, it only takes one negative to throw your answer off, so definitely write this down as you go forward. Now we have a 3x4 matrix. Okay, we'll enter that into the calculator. Even if you want to use A, you can always re-edit, make it a 3x4, and then just go right over top of the numbers 2, -3, 5, and 12, -5, 3, 1, -3, -6, -2, 1, and 30. Okay, go out of the matrix, back into the matrix, math, RREF, and we will call out our matrix A to get this here. So when we use RREF, we get 1, 0, 0, -3, 0, 1, 0, -6, 0, 0, 1, 0. Okay, these ones along the main diagonal, that is key, and then you want zeros everywhere else. This then translates into, we have R equals -3, we have S equals -6, and we have T equals 0. Done. No substitution, no elimination. Isn't that great? Aren't you like, oh my gosh, why didn't you just show me that the first time? Okay, because it's just the grand finale. So that's the idea of it. So nice and easy. You could do these all day now. Now, number 3. Okay, little bit different here. Notice how there's no Z. It's missing. So you do need to kind of fill something in here. It's like a missing tooth. You're just going to need to reconsider this row as plus 0. Z equals 0. Okay, now, again, when you write your matrix down to use, it would be -5x plus, or -5, 2y, well, just 2, 1, and 1. 3, -3, -1, 5, and -4, 1, 0, and 0. So make sure you write that down. Second, matrix. Enter that bad boy in there. -5, 2, 1, 1, 3, -3, -1, 5, -4, 1, 0, 0. Second, matrix. You can go back in and find RREF and all that. Do that here. Whoops. Call out matrix A. You could use any other matrix as you'd like. And -1, -4, and 4 is what we are left with. So you don't necessarily need to write this whole thing down. Just make sure, again, you write down the matrix you start with. Maybe tell me you use RREF, and then you can write down the solutions. In this case, x equals -1, y equals -4, and z equals 4. Okay, and that is all I would really expect of you. Now, just something else to notice. What about no solutions and infinite solutions? So I'll show you what those ones look like, just to kind of give you a full taste here. So number 4, you can hopefully get the idea of this now. 4, -3, -1, 1, 1, -1, 5, we got R, S, T. So T, R, we're actually missing S here. So I tried to go too quick. So think this is -3R plus 0S plus 1T. So something to be careful of. Okay, sometimes I make mistakes, so you guys learn from them. 9, 8, -17. Okay, so always check to see if your R, S, and T's or your variables are lined up. I'm gonna just re-edit the matrix. 4, 1, 5, 9, -3, 0, 1, 8, -1, -1, 4, -17. Okay. Hey, real quick, I did just fix my matrix. I forgot to put a -5 in there, and it gave me a different answer. So -5. Be careful writing that. I'm trying to go too quick. That's my problem. I'm going to do second quit to leave the matrix, go back in. And now, so notice what we get. And it's not scary because we have decimals. Those are okay. What we end up with is a matrix 0, 1, and so it's -1/3. If you ever need to go over, you can always just scroll over in your calculator. Okay, over. Okay, now anyway, the key thing is in this bottom row, if you have all zeros, that just means infinite solutions. If you have all zeros in the bottom row, that is infinite solutions. Okay, that's just a shortcut. Actually, on the test, I will say there is an actual answer, an XYZ answer, but this could be used to maybe check your work. On the other end of the spectrum, if you were to try this one out, so you can even start to hopefully get the hang of writing everything down, and I'm just going to type in the coefficients, -3, -2, 2, and -5, -1, -6, 2, and -8, 6, -4, -2, and 6. And if you use RREF on this one, notice how the last column or the last row is 0, 0, 0, 1. So with RREF, it's saying nothing, nothing, nothing is equal to 1. This is no solutions. Okay, so that's always the case. All the other rows can be anything else, but if that's what happens in the last row, that's the case. So hopefully you appreciated that. You're like, wow, that makes it so much easier. So really your systems of 3 equation should not take you very long to do now. So I encourage you, please go back through your old systems of 3 equations, play around with this method, and definitely you should know how to use this for your own good on the test. Solve each system using RREF. All right, guys, so that's your little treat, wrapping up Unit 3, and good stuff.